Hello everyone and welcome back to the Kohi Game Engine series. And this time, I'm going to get the title right. So in this video, we're going to get started on building out our renderer subsystem. Really quick though, I would like to take a quick second and thank the partners of the channel, Eearslya and Wensheng. The partner is the highest tier of supporter on the channel. And so I just wanted to say thank you to our partners as well as our other supporters that are listed here on the screen. So if you're interested in supporting the channel, there are a couple ways to do that now. First off, I have channel memberships available. You can access that by clicking the join button below this video. I'll also provide a link to a video that I have describing the memberships. And I also have a Patreon page, which is patreon.com/TravisRoman. Thank you all very much for your support. It is greatly appreciated. But before we jump into the renderer subsystem, there is one quick little thing that I want to knock out. So one thing that I've been meaning to do is in our application, we have in a couple places this concept of delta time. And so far we're just feeding through 0. And I want to go ahead and fix that and get that in place because we're going to need to know the delta time between frames for our renderer at some point. And I want to go ahead and knock that out now. That way we don't have to do that later. So to do this, we're actually going to create a clock, and then we're going to use the clock to actually calculate our delta time. So I'm going to go ahead and set that up real quick, and then we're going to jump into our renderer. So under core, we want to create a new file, call it clock.h. Of course, we start with pragma once and include our defines.h. And we want to go ahead and set up a simple structure for our clock. So basically our clock is going to hold our start time, which is a representation of when the clock was actually started. And then it's also going to keep a amount of elapsed time. So elapsed time is actually going to be in seconds, and we're storing these as float 64 so we can get fractional seconds. So that is our clock struct. It's pretty simple stuff. Our interface for the clock is going to be very simple as well. We're going to have a clock update, which can be updated at any time. Generally, you'll want to do this in a loop, but you could technically call it any time, as long as you call it before checking the elapsed time. And this will go ahead and perform some calculations based on the start time to get the elapsed time. And then we have a clock start, which basically sets some state within this clock and says, okay, the clock is running. And then it starts to keep track of this. It sets the start time and then keeps track of this elapsed time. And then we have clock stop, which of course just stops the clock and prevents further updates. So that is all our clock does. It's pretty straightforward stuff. So we need another new file called clock.c. And this of course is going to include clock. And then it is also going to include our platform.h, because platform is actually going to be where we get our system time from. So going ahead and filling out the interface that we have defined here in the H file, I'm going to go ahead and paste some code. So what we have here is our clock update, which basically says if the start time is not equal to 0, which is the default value for our clock, then we're going to go ahead and set the elapsed time to whatever we get back from the current absolute time from the application minus the clock start time. Okay, and that's all the update does. And the start simply just sets the start time to the current absolute time and then sets elapsed to 0. And then when we stop, we simply set the start time to 0. So the only way that the start time will ever be 0 is if the clock is never run, which is its default value anyway. So this is a very rudimentary clock. We probably will be updating this as we go, but for now I wanted to keep it nice and simple so we have something very simple to put in place and use. Okay, so now we need to go into our application, and we'll go all the way to the top here, and we will include our clock. So we'll say include clock.h. And in our application state, we're going to go ahead and right above last time, we're going to create a clock. Okay, so that is all that we need to do for that. And then in the application run, before we actually do anything else, the first thing we want to do is start our clock. So we're going to call clock start and pass the app state clock, and then clock update passing the app state clock. So we're going to immediately start it and and go ahead and update it right away. Okay, so the next thing that we need to do is we need to use this to calculate a delta time. So we already have our last time in our state up here, but we haven't actually used it yet. So we actually need to go ahead and start tracking that now. And so up here at the top of application run, we're going to want to set some defaults. So right after we call clock update, we're going to go ahead and set the app state's last time to the elapsed amount of our clock, which is why we're calling update here. Okay. And then we're going to go ahead and keep some local variables as well. So we're going to have a running time, a frame count, and a target frame seconds. So what we're looking at here is this is going to be our target frame rate, which is 60, and our target frame time is going to be 1 divided by 60, which will give us a 60th of a second for our frame time. And I'm not going to get into totally how we're going to use this right now, but rest assured we are going to need this in several different places to limit our frame rate and so forth. So our running time is basically going to keep track of how much time has been accumulated. So we're going to accumulate time, and then once that time exceeds this, then we're going to go ahead and reset the frame count. The frame count is basically going to keep track of how many frames have gone in a second. So we have a way to sort of track frames per second. Okay. So next, we need to, within our check here to see if the app state is suspended, we need to go ahead and update our clock here as well. So this is the per update loop clock update that we're going to have. So we call clock update. We go ahead and nab the current time, which is the clock's current elapsed time. We calculate a frame delta, which basically takes the current time and subtracts the last time from it. And then we also go ahead and get the start time of the frame so that we can keep track of how long this frame actually takes to render. And that's going to be important later on when we go ahead and start tracking some of our frame times and whatnot. We're going to be doing this in a few different places. So, okay. So the next thing that we're going to want to do is we're going to want to take this delta, and we are going to want to replace these zeros with delta. And same thing goes here for input update. And that one actually just takes the 64-bit float. So now we're actually using our proper delta. And so now that we have all this information, we actually need to run some calculations to figure out how long the actual frame took to render. So I'm going to paste in some code here to do that. And this calculation is going to be done before the input update, because if you recall, we basically want the input update to be done last. So right here, we are going to do some calculations. So we're going to go ahead and grab the frame end time by getting the platform absolute time. And then we're going to see how long it took for the frame to actually go by. And then we're going to add that to our running time. And from here, we're going to calculate how much of a second we have left. And we're going to take our target frames per second and subtract our frame elapsed time from that, and it will give us our remaining seconds. Okay, so we're going to say if we have any remaining time left, we're actually going to give that remaining time, or at least a portion of that remaining time, back to the operating system. And this will sort of keep us from taking up too much system resources and just, slamming the graphics card and the CPU. And so this is sort of a way that we limit that. We basically say, okay, how many milliseconds do we have left? And then if we are limiting the frames, which I'm hard coding to false here, we'll go ahead and perform a platform sleep. Now, I'm turning this off simply because I don't want to necessarily use that. That's going to be something that we're probably going to want to do more so in release builds, but I wanted to get it in here so we at least have the logic in place. Finally, at the end of the frame, after we've actually done our input update, we want to make sure to set our app state's last time to the current time. Okay? And that'll just make sure that that we're constantly updating this last time, so that way we can properly calculate the amount of time that it takes between frames. Okay, so I'm actually going to build this real quick. And I'm going to run it. And as we can see, everything runs fine. But what I'm going to do is I'm going to go ahead and put in a breakpoint here so that we can take a look at our delta and see what value that is. Now that is, looks like our delta is 4.7 seconds. So it looks like we're not resetting the delta for some reason. Oh, yes, we are. Okay. So basically, I was just clicking this continue button too slow. So basically, what we have here is the amount of time that it is actually taking this frame to complete. So if I wait a few seconds, you can see that's why we're getting, you know, these high numbers, is because I'm waiting a few seconds between frames here. So if I actually click this a few times rapidly, you'll note here that we get a fraction of a second. So we know our clock is actually working correctly. Okay. Now that that is out of the way, the next thing that we're going to do is we are actually going to start setting up our renderer. So this is going to require a little bit of structure first. So under source, we are going to create a new folder, and we're going to call this renderer, right? Because it's not really core logic. This is sort of our almost our first really major split off from the core. We have this platform here, but our renderer is really going to be its own thing. Okay, so the way that we're going to set this up is we are going to have our generic renderer stuff, like our front end is going to be under this renderer folder, and then our specific backends are going to be under their own folders underneath this. So if I right click renderer and create another new folder, and we'll call this Vulkan, that is where we will put the Vulkan specific renderer stuff. And obviously we'll eventually have one for OpenGL, DirectX, anything else that we put in here. Okay. So first and foremost, the very first thing I want to create under the renderer is going to be something called renderertypes.inl, because we are going to have several types in our renderer that we are going to want to share across the renderer and potentially even outside of it, that we do not necessarily want to confine to being just within our Vulkan specific renderer. So as with pretty much every other header file, we are going to pragma once and include defines h. And the next thing we're going to do is we're going to set up a quick enumeration of our different renderer backend types. And these are the ones that I'm planning on supporting out of the box for right now. We can always expand on this later, but I want to go ahead and get this in there so that we actually have a way to programmatically say which one we want to use. So we have a renderer backend type Vulkan, that's going to be the one we're going to use, and then we have one for GL and one for DirectX. And we can go ahead and fill those out later, but we will be using this when we go ahead to stand up the actual renderer. Okay, so the next thing that I want to set up is a structure to represent our renderer backend, right? And I'm going to use, this is one of those places where object-oriented programming kind of makes a little bit of sense. So we're going to be using some of that via function pointers. And the way that we're going to handle this is we're basically going to define an interface at this level. And then the specific implementation of that interface will be will actually fill out these function pointers. Okay. The first thing that the renderer backend is going to need is it is actually going to need to know about the platform, and reasons for that will become apparent in the short future. But for now, I'm just going to forward declare the platform state, so I don't have to actually include that header file, and I'm going to store that here. Okay. The next thing is we are actually going to set up an initialize function pointer. So this is the function pointer is called initialize. It returns a B8. It takes in a pointer rather to a renderer backend, takes in the application name, and then takes in a pointer to the platform state. Okay. And since we have an initialize, that means we will also have a shutdown. So that is just return type void, and again, it takes the backend, a pointer to a backend. Okay, the next thing that I'm going to go ahead and set up is something for a resize, and this is for window resizes. I know we haven't hooked that up yet, but I want to go ahead and get this in there. Again, it takes a pointer to a backend, and then the width and the height, the new width and the height of the particular viewport that we're going to be rendering to, which may or may not be a window. And then we have something called begin frame, which returns a Boolean. So if this operation is successful, then we return true, otherwise we return false. It obviously, again, takes a pointer to a backend, and then the delta time since the last frame. And then we have a end frame, which looks almost exactly alike, and returns a Boolean as well. And the way that this is going to work is we're going to call begin frame, which is basically going to do a bunch of stuff to set up the frame to be rendered. And then we're going to do a bunch of rendering, and then when we're ready to tie up things for that particular frame, we'll call end frame. However, if begin frame for some reason fails, then this Boolean will report that to us. And there may be many reasons for failure, and there's also going to be reasons that aren't necessarily fatal. But there may have been something that happened where we don't want to render just yet. Like maybe the window resized and we're restanding up our resources to our GPU on the back end, something like that. That's actually an example of why we would return false there in some cases. So if begin frame for some reason returns false, then any rendering functions would not be called, such as draw functions, things of that nature, and end frame would also not be called. So that is the reason that those are returning Booleans. And for now, that is all that our interface is actually going to give us. So this is pretty straightforward. We're going to be adding a lot to this as we go, but for now I want to keep it pretty straightforward and simple. Okay, so that is it for renderer types. The next thing that we're going to want to do is we're going to want to create the front end. So I'm going to create a new folder under renderer, a new file rather, and we're going to call this renderer frontend.h. And this is going to take, this is going to start off with a pragma once, and then it's also going to include renderer types INL, which already includes our defined instance.h, so we don't need to include that again. And then we're going to for declare a couple structures here. All right, so as with any other subsystem, we have an initialize and a shutdown. The initialize simply takes a application name and then a pointer to a platform state, which again we're for declaring. And then we have a renderer shutdown, which is pretty straightforward stuff. We are also going to have a renderer on resized, which simply passes the width and the height. This is something that we may wind up changing the structure of the way this works in the future, but for now I want to keep it as simple as possible. So the next thing that we want to have is basically our function that gets called once per frame to kick off all the rendering, right? And so we are going to call this renderer draw frame. And we're going to take in something called a render packet. And you can see that we haven't declared that yet because I kind of wanted to talk about what that is. So a render packet is basically a packet full of information that we're going to prepare ahead of time that the renderer will need to know to actually render that frame. And it may contain things like lists of meshes that need to be rendered, camera information, environmental information, things like that. That's sort of all been scooped up and put into a packet and then just tossed over to the renderer. So back in our renderer types INL, we are going to declare our render packet, and for now all we're going to do is pass the delta time. There's going to be a lot more that we're going to include in this as time continues, but you guys will quickly see as we expand this system why I'm doing it this way instead of a bunch of parameters. Okay. So back here, we have our render packet being passed to our draw frame. Okay, so that is, in a nutshell, what our renderer front end looks like. It's pretty straightforward stuff. Again, there are going to be more calls added to this over time, but for now, this is all we need. So before I add the frontend.c file, I actually want to stand up the backend as well, because we're actually going to need to know about this backend before we can stand up the front end. So I'm going to go ahead and under the renderer, I'm going to create another new file, and I'm going to call this rendererbackend.h. And again, note that I did not put this under Vulkan yet, because we are going to have a specific Vulkan backend. So the H file is, of course, going to include our pragma once, our render types, INL, and then we're going to forward declare platform state once again. And our interface is going to be pretty straightforward. So we're going to say our render backend create is going to take in that enumeration type that we discussed before. This is how we're actually going to switch on that. And we are going to pass in the platform state as well as a pointer to the created backend object. Then we are also going to have a corresponding destroy for that as well. And that is all that this file is basically going to contain. It's pretty straightforward stuff. So again, we're going to go ahead under renderer, create a new file, call that rendererbackend.c. And this is where we are actually going to switch. So we're first going to include rendererbackend.h, and next we're going to create our rendererbackend create function, which takes in those arguments. And the first thing that we're going to do in here is set our platform state to the one that was passed in. So we're just basically setting that on the renderer backend. And then we're just going to say, okay, well, if the type is backend Vulkan, then we're going to go ahead and fill this out. I'm just going to put to-do fill out. Okay, and we're going to come back to this in just a second. Okay, and at the bottom of this, we'll say return true. Okay, so if we, for some reason, are not able to create the renderer, something fails, or we do not pass a type that we currently support, we will return false, and the application will know at that point that the renderer was not able to be successfully created. Okay. So the next thing that we're going to want to set up is really quickly our destroy. And again, it's going to take a pointer to our renderer backend. And all this is going to do is basically null out all of the function pointers that will have been set up here. Now, I haven't filled this out yet because we actually don't have anything to point to. So that is going to be the next order of business. But I'm going to do that after I tie this into the front end and hook that up to the main part of the application. So that's why I put a to-do here. We're going to come back to this in a bit. But basically, the way this is going to work is we are going to assign function pointers in here, and that's all this is really going to do. But this keeps the rest of the application from caring or having to know about any of the information as far as what render is being used other than what type is passed in, and that'll eventually be a configurable item that can be passed in on startup. Okay, so now if we create another new file under the renderer, and we're going to call this rendererfrontend.c. Now we are going to go ahead and fill some of this out. So first we're going to include the front end and back end H files. And we're also going to want a couple of utility files. We're going to want the logger and memory because we're going to need those. And we're eventually going to need some other stuff, but I'm not going to include that just yet because we don't need it. I'm trying to keep this as simple as possible. The next thing that we're going to do is we're going to statically hold a pointer to our backend, right? And I'm just defaulting this to 0, but this is where we're going to store our backend. We're only going to have one backend at a time. This may wind up changing at some point, but I really don't see a need to have more than one at this point. So for now, to keep things simple, I'm going to have one backend with a pointer here. And this will also keep us from having to pass around or know about a pointer to our backend from within the front end or really outside of the front end. It sort of abstracts that whole thing away from the rest of the system. So the first thing that we're going to start with is our renderer initialize. Okay, and this is basically going to set our backend here. It's going to allocate some memory for it. So it's basically going to set it, it's going to allocate the size of a renderer backend. It's going to tag it with the memory tag renderer and go ahead and assign it. The next thing that we're going to do is we are going to go ahead and call renderer backend create. And we are going to hard code renderer type Vulkan, which is why I have a to-do in here to make this configurable. Eventually, we'll want to pass a configuration into this initialize so that we can dynamically choose which one of these. But for now, since we only support Vulkan, I'm just going to hard code this. We also pass our platform state that was passed in here, and of course a pointer to our backend, which is up here. Okay. The next thing that we're going to do is we are immediately going to call backend initialize, right? And if this returns false, then we are going to say, hey, we couldn't render a backend, and we're going to boot out of this entirely. We're not going to allow the application to actually run. For now, that is actually all that we're going to need to do. So I'm going to say return true down here if all of this is successful. Okay, so that is it for initialize. Shutdown is pretty simple as well. So all this does is call backend shutdown, passing of course the backend pointer. And then, so we don't leak the memory, we are going to call kfree against our backend, of course passing the appropriate tag so that we go ahead and clean up that memory. So next we need to fill out renderer draw frame. So this is where the application is actually going to call in to say, hey, we need to go ahead and perform all of our draw operations. So the first thing that we're going to want to do is we're going to want to call begin frame. This is where I was saying we pass in the packet delta time, and then if that's successful, we'll go ahead and continue, otherwise we won't. Okay, and for now this actually isn't going to do much of anything. There's going to be a lot of things we're going to have to fill in here, but the main portion of this that we're going to want to do is we want to go ahead and end the frame, and if for some reason the end frame fails, that's really bad and we're probably not going to be able to recover from it. So if that happens, we are going to then say throw an error and return false. That draw frame actually failed. Okay, otherwise we're going to return true. And in fact, return true. Okay, so as I mentioned before, the renderer begin frame returning false is not necessarily an error. There may be many reasons why that could happen. So in that case, we'll always want to return true. But if end frame actually throws an error, that's a problem. So this is how the draw frame is going to be set up. Now, we don't have these renderer begin frame and renderer end frame set up yet, so let's go ahead and do that. So I'm going to put this right above draw frame. So we have our begin frame, which basically calls the backend begin frame, as you might expect. And then our end frame does almost the same thing, except we're actually going to increment something called frame number here, which actually we have not added to our backend. So let's go ahead and add that. Basically, what this is going to keep track of is how many frames we've actually rendered on our backend. So that's could be a useful thing for debugging. So we always want to keep track of what frame number we're actually on, and this just increments that, right? So this also means we probably, when we go ahead and create this backend, we probably ought to go ahead and zero out its frame number as well up here. Okay, so that is begin frame, end frame, and our renderer draw frame. Now, one question you might be wondering is basically how do we generate this packet, and where should we do it? Well, for now, we're actually going to generate the packet in the application, but we're probably going to wind up moving that eventually to the renderer itself. But for now, for simplicity purposes, we'll go ahead and generate it in the application. So let's go back to application, and we'll go to the top. All right, and we'll say right down here, we'll go ahead and include our renderer front end, since that's actually what we need to go ahead and stand up. Okay, so in our application create, we are actually going to go down, let's see, right before we initialize the game is where we're actually going to stand up the renderer. Okay, so this has to be done after the platform startup is done. Okay, so application state. Why is that saying that's incompatible? Need to pass a reference to that, I believe. Right, okay, there we go. Okay, so now we have all of that in place. So that's our initialize. The next thing that we'll need to do is go ahead and hook this into the update loop. So let's go ahead and do that. Okay, so what we're going to want to do is look within our loop here. So right after the render, we're going to want to call render draw frame. And now we have this packet here. So what I'm going to do, at least for right now, is I'm going to do something kind of gross. And I'm just going to create this every time. And we're eventually going to want this to be something a little bit more robust than this. But for now, we can just pass through the packet like that. So we'll just create the packet every frame and pass it through. Again, this is not doing much. We're eventually going to have something way more robust than this. But for now we're just going to go ahead and hard code this here so that we can get this up and running. So finally, down here, right before actually I'll say after our input shutdown, but before our platform shutdown, I'll call renderer shutdown. Okay, and so now our renderer is actually hooked in properly, so I should be able to go ahead and build this and run. And right, because we didn't actually set up any of our function pointers, so that's actually to be expected. Okay, so the next thing we need to do is actually create our backend. So for now, the first step of this is going to be kind of simple. So under render Vulkan now, we are going to say create a new file, and we're going to call this Vulkan backend.h, and this is going to include it's going to pragma once and include our renderer backend. We're going to have a interface that looks almost exactly like our backend here. So we have initialize, shutdown, resized, begin frame, and end frame. So we are setting up Vulkan renderer specific versions of all these. So the function signatures here are all exactly the same. Okay. So I'm actually going to copy these, create a new file, call it Vulkan backend.c. include Vulkan backend.h, paste these guys in. Okay, so for now, this is not going to do anything, or I should say this resize is not going to do anything. The begin frame is just going to return true, and the end frame is going to do the same. So we're not going to do anything with those just yet. The important bit is here in the initialize. So the next thing that we're going to want to do is create a Vulkan types INL file. This is basically where we're going to define the Vulkan specific types for everything. So of course we do a pragma once and defines. We are going to want to include vulkan.h here. So that way we don't have to include this all over the place. We can just include this types INL file, which we're going to need everywhere anyway. And we will from there go ahead and create our additional types down here. Now right now we don't necessarily need much of anything, so I'm just going to leave this as is for now and go back to our backend and include Vulkan types INL so that we can go ahead and get that Vulkan include. Okay, and our backend is going to be pretty straightforward. So one thing I probably ought to go ahead and add, actually I was going to try and skip this, but I think I should probably go ahead and get it in here. Our Vulkan context. So our context is going to be specific to this particular renderer, and it's going to be where we need to hold sort of all of our static data for this particular renderer. So if you recall back to our previous conversation, one of the things that we needed to store was the Vulkan instance, and that is a VK instance. So everything in the Vulkan library, as far as I know, actually is prepended with VK something or other. And in this case, the handle to the instance is VK instance, is the type there, and we're going to store that off as instance. So the very first thing that we're going to want to do is keep a copy of the instance. And we're going to be storing a lot of other things here too as we go on, but this Vulkan context object is going to be extremely important and passed around and used everywhere. So that is probably going to be the first thing that we're going to want to actually set up. And similar to how we did the backend, we are actually going to statically create our Vulkan context because we only need one. So our static Vulkan context will be up there, and then this, and since this is static, this will already be zeroed out, so we don't have to worry about that. And really the only thing that we need to do is create the instance. So this is actually extremely simple. And to do this, I'm going to start off by pasting some code, and then I'll explain what's going on here. So anytime you create a handle to something in Vulkan, which Vulkan deals with handles for almost everything, you typically have some sort of creation info to go along with that. So here we have this application, this VK application info structure, which gives Vulkan a little bit of information about the application itself. It says what version of the API we're targeting, which is actually pretty important. The application name, version information, which we don't really care about because this is just engine and application version. We don't care if Vulkan really knows about that. This is usually for the larger engines like Unreal and stuff. These will actually matter, but for us it doesn't really matter. And the engine name is just Kohi engine, right? So I don't think that Vulkan actually really cares too much about this stuff. This is really just information for the application to use, but debugging tools could potentially look at this stuff, and that could help you figure out what is actually running at that point as well. Okay. So the first thing that we're going to do is we are actually going to create our VK instance. But to do that, as I mentioned, we need a create info. And you're going to see this pattern a lot. But basically what we're doing here is we're creating a new structure. And then the very first, if we actually go into this, the very first item of all of these VK create info structures, and by extension a lot of the structures in general, the very first property is always going to be this S type. And this tells Vulkan what type of structure it is. And so in this case, we need to make sure to use the VK structure type and then instance create info. So you'll notice that everything after VK structure type matches this here. So we have instance create info, instance create info. VK structure type is for the S type. Okay, so this pattern, you're going to see this a lot throughout the code. Then we're going to pass a pointer to the application info that we created up here. It should be noted that this is actually safe to pass the address of this, because once we actually create the instance, all this gets thrown out anyways. It's not mutable at that point, so there's no sense in holding on to any of it. Okay, so for now, we actually have a couple of other things that we need to put in here. And I'm actually not going to go into what these are in this video. We're actually going to tackle that in the next video. But they do need to be zeroed out, because if they're not, Vulkan will bleat about that. So the next thing that we need to do is we need to call the actual creation method that gives us our instance. Okay, and again, this follows a specific pattern. In this case, it's VK create instance. We pass it the create info, and then we pass it allocation callbacks, which is if you're using a custom allocator, which we actually are not. I'm going to pass 0 for there right now. You notice I had a context allocator in there. I am going to, in fact, you know what? Let me not cut that corner. Let me actually go fill it out. So an allocator is basically Vulkan allows you to create your own custom allocator. Memory allocator. You can pass null to just say use the driver's default, and that's what we're going to do. But I want to actually have the ability to use our custom allocator. So I could just pass 0 there as I showed, but I'm actually not going to do that because I want the ability to swap that out later, and I don't want to have to go back and refactor a whole bunch of code to actually make that happen. So in our render context, right under the instance, we're going to just have a pointer here to a VK allocation callbacks, which is our allocator. And when I create the Vulkan context, I'm actually going to say context.allocator equals 0 to do custom allocator, right? And this has an interface that you have to meet and all that. And we're not going to do that right now. But I do want to at least create a place for that, so that if and when we do get to it, we can actually go back and handle that. So anyway, back to VK create instance. So VK create instance takes our create info, takes our allocator, which is nothing at this point, so it says just use the default, and then it takes a pointer to whatever, basically where we're going to store the handle, right? And this VK create instance returns a VK result. So we're going to go ahead and store that. Okay. And one thing, whenever you have something that takes a result, you always want to check it. So we want to say if result is not equal to VK success. Then we're going to go ahead and bleat about it, right? So we'll say, let's see, do we have our logger? We do not have our logger. So let's go ahead and include core logger.h. We will say k error, and we'll say vk create instance failed with result. And this, if I recall correctly, is just an enumeration, so we will treat that as an unsigned integer for now. Result, and then return false. Okay. Otherwise, if it is successful, we'll go ahead and you know what, we'll say k info Vulkan renderer initialize. Vulkan renderer initialize successfully and return true. Okay. All right. So that is pretty much going to do it for right now. For that, let's go ahead and what is this? This says we have an error here somewhere. Oh, somehow I'm missing a closing parenthesis there. Okay. All right. So that is it for our Vulkan backend, at least for right now. So we'll go here and into our renderer backend, and we will fill out the function pointers. So to do this, we'll need to include Vulkan backend.h. Okay, and we'll get rid of this to do and paste in our code to set up the function pointers. So initialize points to Vulkan renderer backend initialize, shutdown points to shutdown, and etc. all the way down the list, right? And so every time we add something here, we just need to make sure that that is actually set up. Okay, and so let's go ahead and build this. Okay, and run. And we can see nothing here, but we actually see a new thing here that says Vulkan render initialized successfully. So we know that at least by all of this, that Vulkan is actually properly linked and all of that. We can compile, build, and run, and all the calls are actually being made. So this puts us in a pretty good position to go ahead and start building out our renderer. So this is going to be a long road ahead. Be prepared for that. It's going to be a while before we see anything on the screen in terms of visual updates. But you know, this is Vulkan that we're dealing with. It's a big boy. So anyway, with that, I hope you guys enjoyed this video. I hope you learned from it. If you haven't already, go ahead and hit that like button there. Consider subscribing, and go ahead and hit that little notification bell there to get notified as to when the next video in this series drops. Anyway, I'll see you guys